Welcome to Supply Chain Management. In this video, we're talking about the factor rating and the center of gravity method to determine the location of a distribution center. At the end of the previous video, we were talking how important of a strategic decision is determining the location of the distribution center because it has significant impact on costs. So in this video, we are going to review two methods to determine a distribution center location: the factor rating method and then the center of gravity method. Let's start with the first one. The factor rating method is used for comparing existing facilities and selecting the best one based on the company-specific factors and ratings. So in this case, the idea is that there are several distribution centers that can be considered, and the company is trying to compare them and determine which is the best fit for that company. You have to keep in mind that most companies, most manufacturers don't own their own distribution center. They usually rent that space and the services from a service provider. And this is sort of what we are evaluating in this situation. For the factor rating method to be computed, we have to follow 6 steps. And in the next slides, we're going to go through each of them, starting by determining the relevant factors the key success factors, and these are very specific to each individual company. So key success factors are selected by the individual companies depending on what the specific company's needs are. So here we have a few examples. Consider that usually in real life, we would have a list of 30-40 factors to evaluate distribution centers on, and they can vary quite a bit, again, depending on the needs, maybe the type of product that the company is manufacturing or shipping. So in this case, we are considering labor pool and climate, proximity to suppliers or to customers, so depending which one is more important, for example, for a company, wage rate, proximity to a harbor, so to a port, and land price. As I said, many more could be added. The second step in this method is assign a weight for each of these factors. So which of these factors is most important for that specific company? If we're looking at this example, we would say that proximity to supplier is the most important factor, while wage rates, proximity to a harbor, and labor pool and climate they're important, but they're less relevant. You notice that how all these weights should add up to 1. So they are all percentages, so they should all add up to 100%. Step 3 is creating that scoring scale for each factor. So it looks like in this example, we're going to look at 3 distribution centers, so 3 locations, and we're going to evaluate each of them on a score from 0 to 100 for each of the factors. So here are some of the scores as provided in the example. It looks like for this company, location 1 scores the highest as far as proximity to suppliers, so they must be located very close to the supplier, while location 2 scores highest on proximity to customers, and location 3 is really close to a port. So this is why they score the highest among all their scores on these factors. The next step, step 5, is very important, and that is determining the weighted scores. So it's not that we just score them on the factor. Remember that each factor has specific weight. So this is what we are taking into consideration now. So for example, we are going to look at each score and multiply it by its weight. Location 1 scored 80 on labor pool and climate, and the weight was 0.1. So we'll multiply 80 by 0.1, and that's how we get the weighted score of 8. You see how location 2 instead would be 65 times 0.1 and gets 6.5 as a weighted score. And so we will go down each of the factors. So for location 1, the proximity to supplier was worth 100, so it scored super high, and it had a really high weight, 0.3, so they get a whole 30 point just for this factor. And so we go on and finish the entire table, and as the last step, what we would do is actually sum up all these weighted score per location, and we give a final score. In this case, location 1, so the distribution center number 1, we're evaluating, scores totally 81 points, and we repeat this for the other 2 locations. And as a final step, we're going to select the location with the highest total score, and in this case, it would be location number 2 with 82.2. So what we get out of this method, we're saying that the distribution center number 2 that we are evaluating seems to be the best fit out of these 3 locations for the company. There is another method that is popularly used, and that is called the center of gravity method. This is used for locating a new single facility that consider existing facilities. This seems tricky to reading it like that, which means is we don't yet have the location that we want for our distribution center, but we have some existing facility that we want to consider, such as the location of our factory or where our customers are located, our suppliers. So based on the distances of, as an example, factory, suppliers, customer, etc., then we can determine where, in which area we would like to have a distribution center. And we're going to use the distances and the volumes of goods that are shipped between these customer, suppliers, and possibly factory of each company. What we will do will be computing the coordinate of a 2-dimensional point that meets this criteria of distance and volume. It seems abstract, so let's look at a more concrete example. Here is the formula that we will be using, and it looks a little bit daunting, but actually, trust me, it's quite straightforward. I remind you that this symbol means sum or adding, right? So what we're going to do, we're going to compute the x coordinate and the y coordinates of our ideal location for a distribution center, and we will use the x coordinate and then the volume of each of the facilities that we want to consider, for example, the location of our suppliers or customers or our factory. And we're going to multiply this coordinate by the volume of each of the locations, and we'll divide them all by their volumes again. And this to calculate the x coordinate, and then we'll do the same looking at the y coordinate for each of the locations. Again, let's look at this in practice, how it works. We have an example. We have several showrooms. We have 3 showrooms here located in this grid. So we have showroom A, D, and Q with these specific coordinates. You see how we have a y-axis and an x-axis. So A would be located at 100x and 200y. D instead has a 250x location, and the y coordinate is 580. And Q is a further out, a bit more distant showroom, and is located at 790x and 900y. So this is where we have our x and y coordinate for each of the location that we want to consider. Each of these locations also has a certain volume that they sell, and here they are listed. So you see that Q seems to have the highest volume, even if it's located further out. So based on these locations and these volumes, we want to determine the ideal location where we want to place a distribution center to minimize transportation costs. So what are the steps to determine where we want to have this new warehouse or distribution center? Step 1, identify the y and x coordinate for each of the location, which we just did. Let's have the volumes. Here we've done it, check. And next one will be applying the formula. First, we calculate the x coordinate, and here is our formula. So we're going to have the distance of, for example, we have here location A by the volume of A, and we'll divide all the locations together. Let's see how it works. We have the x coordinate of A is 100, and we multiply that one by the volume of A. See that? And then we repeat the same for the location D. We have the x-coordinate is 250 and 1900 is the volume. And of course, here is the same for location Q. And at the bottom, we just add all the volumes together. Simple as that. And you can see that if you compute the numbers, the new coordinates, so the coordinate for the new warehouse would be 443x. Next step, of course, is to calculate the y coordinate. And the calculations remain the same, except that instead of the x coordinate for each location, we're going to use the y coordinates. So the volume you see is, of course, remain the same as well as the one on the bottom. And the new y coordinate will be 627, so almost 628. So how does that look like? Now we have x and y coordinates, and this is where the new warehouse should be, at 443x and 627, almost 28 y. So if we have a new distribution center there in location Z, we would minimize the transportation cost to support all these showrooms. So in this video, we talked about factor rating method, which compares existing facilities, so we know which distribution center around area Z we would find. And center of gravity method actually decides for us, helps us locate a new single facility or area, considering distances and volume of supplier and customer's location that we care for. I leave you with the last knowledge check, trying to identify each activity to which method it belongs.